Okay, so we're going to go ahead and continue with the notes that we were looking at before spring break. These are the notes here, solving trig equations. It's got this graph on the front. I do have extra copies if you need one. Does anybody need a copy of the notes? We got this before spring break. I don't remember exactly what day. We've gone through about half of it. That's okay. All right, anybody else? Nathan needs one. Lily Bell. Mm-hmm. Okay, Leo needs one. Okay, anybody else? Okay. Oh, Jalen needs one. Okay, Kirsten needs one. Okay, so all the problems that we've been pretty much looking at up to this point are the first half of the paper, that we've been studying. What I want to go ahead and do now is kind of look at another type of quadratic, okay? Because we haven't seen any. We've seen some quadratics, but you can always pull out a common factor. But what if we have a quadratic where you're not able to pull out a GCF? We'd still want to be able to solve those like we have been in the previous equations. So before we go ahead and get to those examples, and we're going to be skipping around this packet, let me go ahead and give you just a normal quadratic so we'll remember how to factor it, and then we can go look at a quadratic trig equation. So let's say if I were to give you 3x squared minus 13x minus 10. Okay, so this guy's equal to 0, right? Okay. Well, do you guys remember what's the method that I like to factor a trinomial? What does my father drive? A red Mercedes convertible. So, see, you'll notice here there's no GCF for me to pull out because there's a constant. So what I'm going to do is multiply the first and the last term. Remember, that's what the first M stands for, multiply. So what is 3 times negative 10? Okay, negative 30. Now, because that's negative, I know I'm looking for a negative and a positive factor. But whatever two I choose, they have to add to give me the negative 13 in the middle. 15 and 2, but which is which? 15 is negative. Okay. And again, wait a minute, why couldn't I have said positive 15, negative 2? Because that's still negative 30. There you go. It would have given me positive 13. And remember, the signs are going to be really important to us. Okay, so I've multiplied. I've factored. What am I going to divide by? Okay. Whatever that first coefficient is, we're going to divide by that. Now what? Okay. So here's the thing about this one strategy. The 2/3 will not reduce. It won't simplify. But negative 15 over 3, that is negative 5. Remember, the only trick here, you have to leave it as a fraction because we need both the numerator and the denominator to create my group. And this is exactly what we're going to do. Once you have those fractions, let's see, like this one here, would that be 1x minus 5 or a negative 5x plus 1? There you go. You always start in the denominator and work your way up. So this would be 1x minus 5. What would the other one be? 3x minus 2. Okay. Equals 0. And you guys remember yesterday I was showing you a property where if you're multiplying items and they equal 0, how would I solve this? The zero product property. That is exactly right. There you go. Take the first one. Set him equal to 0. Okay. Take the second one. Set him equal to 0. So x equals 5. Subtract the 2. Divide by 3. So there we go. Now, exactly what we just did there is what we're going to be doing on these quadratic trig equations. Okay. So if you'll go ahead, let's see, which problem do I want to take a look at? That's not it. Okay, let me see. What problems am I wanting to do here? It's not 5 and 6. We actually already did those. I need 10 and 11. Here we go, 10 and 11. Okay. So these are some examples of some quadratic trig equations. Okay. Now, what we've seen so far, we have seen quadratics. That hasn't been a problem. So if I haven't had that constant there, you'll notice the two terms both share sign. So I could just factor it out, use the zero product property, right? Well, the fact that we have a constant here, it's a trinomial. instead of a binomial doesn't allow me to do that.
Can we just change, like, can we like delete the sign and just make them X?
You could if you want to. In fact, we've done that before with other values. If we just go ahead and say that x equals sine of x, then we could rewrite this as 2x squared minus x minus 1. Okay, now let's go ahead and factor this exactly as we did the previous one just a moment ago. So I'm going to multiply the first and the last. So what's 2 times negative 1? Negative 2. Okay, so again, I've got a negative, so I'm looking for a negative and a positive. Well, the only factors of 2 are 2 and 1. The only question here is which one's got to be negative? It's got to be the 2. So the 2 is negative 1. What am I going to divide these by? Okay, that is your leading coefficient. So divide by 2. Divide by 2. Reduce. So negative 2 over 2 would become negative 1 over 1. The 1/2 would not reduce. Okay. Now, what we want to go ahead and do is use those fractions to create my binomials. So what's this first one here?
X minus 1.
Okay, so that would be x minus 1 times
2x minus 1.
2x plus 1. There we go. So is everybody okay with how we factored the trinomial? Okay, so now I'm just going to go back and replace x with my trig function. So x minus 1 is actually sine of x minus 1. 2x is actually 2 sine of x plus 1. There you go. And see, now it's a problem like we're accustomed to solving. We can now use the zero product property. Okay. In fact, one of these is going to be sine of x minus 1 equals 0. The other one's going to be 2 sine of x plus 1 is equal to 0. Now remember, we're only solving it on the one interval between 0 and 2 pi. Okay. So how would I solve this first one for sine? Add the 1. So if I were to add 1, those cancel. So sine of x is equal to 1. So what am I really looking for on the unit circle? Any location where a y value is 1. Now let me see here. I think my unit circle is right there. So it's not allowing me to move it. Let me go ahead and use my mouse here to do this. So we're on this one. So I want to move it right there. There we go. Okay. So just so I have it a little bit closer. So where on the unit circle do I have a y value that's 1? Looks like pi over 2, so 90 degrees. Is there any other location? Nope. So for that one part, there's only one answer. So I'm going to come back over here, x equals pi over 2. Now I'm going to move to the other one. Okay, well here I'm going to have to do two things. I'm going to subtract the 1. Okay, so 2 sine of x equals negative 1, and Marcus tells me to divide by 2. So now I want to know, where does sine of x equal negative 1/2? So again, I just want every location where there's a y value that's a negative 1/2. So where am I looking?
2 pi over 3.
Okay, so 2 pi over 3. Okay, now there's a negative 1/2, but it's a what? It's an x. Remember, we want sine. Now if it were cosine, that'd be perfect. So 7 pi over 6, there's a y negative 1/2. And 11 pi over 6, there's a negative 1/2 as a y value. Okay. So I'm going to come back over here. All three of my answers, I'm going to say the pi over 2. Then we just found 7 pi over 6 and 11 pi over 6. So in one revolution, there are 3 answers that would give me a solution to this equation. That would make it true. Okay. So the only difference with these is you're just solving a quadratic. Okay. Does that make sense? Okay. So with these quadratics, with the 3 terms, you know, we can't just pull out the GCF as we've been doing. Okay, let's try number 11. 6 cosine squared of x minus cosine of x minus 2 equals 0. Okay. We can. Okay. So let me go ahead and get rid of all this right here. In fact, we don't need this. Let me get this out of the way. And we don't need that. Okay. All right. So let's run through. Did you guys want to go ahead and try factoring this on your own just for practice? Okay. Let me go ahead and give you a minute. Now I'm going to do the same thing. I'm just going to say that our trig function cosine is equal to x. Okay. And remember, you can use whatever variable you want. It doesn't matter. So 6 cosine squared is actually 6x squared minus cosine of x, so just minus x, minus 2 equals 0. Now, if you don't need to pull out the cosine, if you can factor it using that, please feel free. I mean, this is just if it helps you. So let's see. My father drives a red Mercedes convertible. Okay. So you may not be done, and that's okay, but let me see if I can catch up to you real quick. I'm going to start by multiplying 6 by what?
6 by -6.
Okay, so that gives me negative 12. So again, I'm looking for a negative and a positive, but I need to end up with a negative 1.
-4 positive.
Perfect. Negative 4, positive 3. Is everybody okay with that? Okay. They're the only factors that are 1 away from each other. What do I do next?
Oh, my bad. Add 6 under.
Okay, so we'll divide by that leading coefficient. Over 6, over 6. So now we'll reduce. What's negative 4/6? Negative 2/3. 3/6? 1/2. Okay. Now remember, we're still going to do this in terms of x. So what would negative 2/3 give me for a group? 3x minus 2. And then what's the other one? 2x plus 1 equals 0. Now that I've got it factored, I'm just going to replace x with the trig function. So this actually should be 3 cosine of x minus 2. 2x plus 1 would be 2 cosine x plus 1 is equal to 0. Okay. And we've seen this, since yesterday. What do I do to solve it? Zero product property. So each of these groups, I'm going to set equal to 0. So 3 cosine of x minus 2 equals 0. 2 cosine of x plus 1 equals 0. So let's see here. If I were to add 2 and divide by 3, that's going to give me positive 2/3. Okay, so cosine of x is equal to 2/3. Okay. And then this other guy right here, cosine of x equals negative 1/2. There we go. Okay. Now, sometimes this is going to happen, not a whole lot. Let's start with the easy one first. Cosine of x is equal to negative 1/2. This one's actually like an exception to the rule. A lot of times you can use technology, but we're focusing on just the unit circle. So what am I looking for this time? An x, y, a ratio, what? Why an x? Because it's cosine, right? So I'm looking on the unit circle. I want every location where an x value is a negative 1/2. So what am I finding? Where is a negative 1/2 for x? Okay, I heard 2 pi over 3. So there's a negative 1/2 for x. And then a 4 pi over 3. Okay. There's a negative 1/2 for an x. So those are 2 answers coming from that one. 2 pi over 3 and 4 pi over 3. Okay, perfect. 2 pi over 3, 4 pi over 3. Now, here's the thing. We don't see a 2/3 on there, but that does work with our intervals when we take the inverse. So this is one of those times where we're going to go ahead and just take the inverse trig function. So I don't have it pulled up right now. But you remember on your calculator, if cosine of x equals 2/3, Okay, well, let me do this right here. Doop, doop. There we go. If cosine of x equals 2/3, then I know cosine inverse of 2/3 should give me x. Okay, so let's see here. Okay, so trig, cosine inverse, okay. Escape, 2 divided by 3. 48.1. Okay. Now mine's in degrees, so if I did want it in radians, what could we do? We could change the mode, but how can I just change this one if I wanted to? Pi over 180, there you go. So I can multiply that by pi over 180. So this one we'll just go ahead and leave in degrees. But here's the thing, this one is actually going to give me 2 answers. And how do we know that? Let me come back over here. Okay. So one of the answers we got, what was it, 48.3? 48.3 degrees. But now think about how we started this lesson. When we first started talking about these, before we went to the unit circle, we were using the coordinate system here, right? Well, what 2 places is cosine going to be positive? The first and the second, okay? So you remember how we drew some triangles there to help me out? Okay. We actually don't have to do the Pythagorean theorem here. Okay. What we found, because it gave me this one right here a positive number, this is 48.3 degrees right here. Well, you remember, what did I tell you about all those triangles that we created? They were always what?
They were always what are they called? I don't know. But I know it's like the 36, 90, and 45, 45, right?
True, but not in this case. These triangles were always going to be identical. So if this is 48.3, this right here would be 48.3 as well. See, we don't need to know the side lengths, but I do need to know what these 2 measures are. See, I already have the 48.3, but how can I figure out how far I rotated to have 48.3 left over? Would it be 360? 180. 180. 180 minus this previous one. So 131.8 degrees is the other answer. Okay. Now this one was kind of a fluke. It actually had answers that we had to approximate that we couldn't get off of the unit circle. I'm not going to be giving you any of those. Okay, I am positive. Okay, I just kind of wanted you to see one just to let you know that you can still find the actual decimal answer in the calculator. Everything else, so the quiz on Thursday, the test next week, you will not be getting any of these decimal answers. We're going to be doing exactly what we've been doing with the unit circle. Okay? I just kind of wanted to show you one that was a little different. Now, as far as the quadratics, are we okay with those? Seem to be okay? All right, well, there's really only one type of problem left for me to show you. We should be able to wrap this up in the next couple of days, and we'll be able to start vectors next week. Okay. Okay, what? One more time.
Billy Rock.
Millie Rock. What is that? Is that a dance? How do you do it? Okay. I don't know. What's Millie Rock? How do you do that? Anybody want to stand up and show me? You're sitting down, show me. You're just kind of shaking your hands. Shake it and you throw it. Oh. Like that? Is this something representing something bad? Because Lexi's over here. Oh. Okay. Oh, okay. I don't know. Okay. Well, there you go.